Hi guys, greetings of the day. This is Vijay Tavatan. Welcome to my YouTube channel for learning a subject called as Fluid Power Systems for 7th semester and Fluid Power Engineering for 5th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let us start the session number 8. We will have a discussion with respect to the beta ratio. What is called as beta ratio? By definition, beta ratio is the number of dirt particles larger than a given size particle in the upstream of the test filter to the number of dirt particles downstream of the filter under the same pressure drop downstream of the filter under the same pressure drop condition. Under the steady flow condition, mathematically, beta x will be given as number of upstream particles which should be greater than or equal to x and the number of downstream particles greater than or equal to x, where x is the particle size in microns and the ratio of 1.0 means that no particles are arrested or held. Beta x is a dimensionless quantity or number. Beta x is also called as degree of separation. Then what is called as beta ratio and how we need to calculate it? The filter efficiency we are going to calculate beta ratio minus 1 divided by beta ratio into 100. Now for example, if the value of x is equal to 2, then filter efficiency will become 2 minus 1 by 2 into 100, which is nothing but 50%. In the same fashion, if the beta x value, that is x is equal to 3, then the filter efficiency can be calculated by 3 minus 1 by 3 into 100, which comes out to 67.67%. And there is a table where you can refer if the beta ratio and the beta ratio efficiency. The beta ratio, if it is 1, it is 0% efficiency. And if it is at 2, the 50% efficiency, and so on. And when the beta ratio is 1000, the beta efficiency is going to be somewhere around 99.9%. And when it is 20, it is going to be a 95% efficiency. This is what the beta ratio efficiency table for your easy understanding. Then coming to contaminants. The worst enemy of these precision made component is the contaminations in the fluid, which may be both solid or liquid. The solid contaminations are dust, dirt, worn out metallic pieces and other particles, and liquid contaminations like water, acids, paints, etc. Then coming to the different types of contaminations in general what we have. For reliable operation of hydraulically controlled system, an absolutely clean fluid is essential. The common contaminants in the fluid may be in the form of particulate matter. Either it could be a dust, dirt, or metallic particles. It could be fibrous or elastomers, etc. Then water, air, and chemical reaction products such as gums and sludges, etc. And other non-compatible fluids such as acids, paints, varnishes, etc. It is a common experience of the hydraulic design and the system designers is and maintenance staff that 50% of downtime of hydraulically operated system is due to dirt in the hydraulic fluid. And what are the different sources of contamination which is going to happen? Either it could be built in the metallic chips during the manufacturing such as welding scales, lapping compound, sand form, casting particles of the metal during the machining, etc. Then generated within the system during the operation. Excessive fluid velocities erode the inner surface of the pipes and component surfaces and add it to the fluid. Coming to external source, air entering the reservoir contains the dirt and moisture which causes formation of rust on the walls of the reservoir and get into the fluid. Then coming to generated during the maintenance, frequent opening and closing of the system, exposing the system for unfavorable environments, addition of fluids to the reservoir during filling up operation, etc. And during the assembly stage, pipes can form pipes and not cleaned thoroughly, corrosion and rest of the components stored in the unfavorable condition, and surplus achieves materials during the mounting of sales, packages, etc. Then coming to acid byproducts like sludges, elastomers generated by the seals and air-blown solids. Then coming to what are the effects of contaminations. A solid contaminates affects the power transmission, cooling process and lubricating ability of the hydraulic fluid. And solid contaminates interface with the power transmission by blocking or plugging the small orifice in devices such as pressure valves and flow control valves. The action of valve is affected, which are unpredictable and unsafe. And solid contamination interfere with the cooling process by forming sludges on the walls of the reservoir, and the heat transfer from the fluid to the reservoir wall is slowed down during the process, and the operating temperature of the system is going to be increased. And the most serious effect that the contamination can have on a system when it affects the lubricating ability of the fluid. And this can happen in several different ways depending on the size of the particles. When the size of the particles are smaller than the clearance provided for the lubrication, can collect in the clearance and finally block the flow in the lubricating fluid flowing into the clearance. Accumulation of the particles in this type is known as silting. The size of the particle is equal to the clearance size. They enter the clearance, rub against the moving parts, break down the film lubricant, and cause wear and damage to the surface of the component. Wear enhances the contamination, increases the leakage, and lowers the efficiency and generates the heat. This is a problem is more in the high pressure fluids, and the figure shows the influence of dirt on dirt particles contaminations on the lubricating fluid. Then coming to temperature control. Temperature of the working fluid also influences the performance and hence the efficiency of the hydraulic system. Excessive heat hastens the oxidation of the fluid and reduces its velocity and viscosity. This leads to deterioration of seals and packings and accelerates the wear between closely mating parts such as valves, pumps, and actuators. The three common types of devices used for maintaining the operating temperature of the fluid are heaters, air coolers, and water coolers. What is called as heaters? An electric coil heater is installed in the reservoir below the level of fluid and close to the pump. The low power heater with the thermostatic controller heat the fluid without burning it. Coming to the air coolers are expensive coolers and power required to operate is less when compared to the water cooler. The fluid is pumped through the tubes and made of aluminum or some of the other metal provided with fins on its surfaces. Heat present in the fluid is transferred to the outer surface of the tube and is dissipated to atmosphere by blowing air from the cooler. The figure shows the typical air cooler. Then coming to the water coolers. Water cooling is the most common method employed for cooling any system. The figure shows the cell and heat exchanger, which is fitted in return line to the tank, and the cold water passed through the tube surrounded by hot fluid. Water flows in the opposite direction of the flow of the fluid and is termed as counterflow cooler. Heat removed from the fluid from the water can be regulated thermostatically to maintain the desired temperature. And the clean water should be used to avoid the cooler from clogging. By circulating hot water instead of cold water, the heat exchanger can be used as a heater. So by thus, the module 1 is completed in all aspects, and there are some few questions which can be treated as an assignment question for the references purpose. Now, by this I can say that the module 1, the all sessions have been completed, and this completes the first module of fluid power systems or fluid power engineering. And thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tamankan.